Okay, so we're going to be doing 100 rolls of 2 dice. In order to do that, we need to set up something for our first dice. So ran between 1, 6, and similar thing here for roll 2. And then we can take these rolls and you could drag them down. We could also scroll down until we get to 101. And paste. So that gives us 100 rolls of the dice, but we do need to add them up. So we just add whatever number this is plus whatever number this is, and double click there to get the sum. Let's put in one more column here. Notice these keep changing. I'm going to go ahead and freeze this here by pasting special. So these will continue to change, but these are the ones that I'll work with for the test here. So the question I'm answering here is, when rolling 2 6-sided dice, is the average different from 7? So my null hypothesis mean would be that there is no difference from 7. So if that's the case, my mean would be 7. My alternative, notice here that I did not specify whether it was going to be lower than 7 or higher than 7. So my alternative would just be mu not equals to 7. And by the way, by setting all the characters here and the number alone in the cell, it allows me to use this number directly in formulas. Okay, next thing, level of significance alpha. Unless otherwise told, we're just going to use that default of 0.05. Sample size. So I've technically rolled 200 dice because there's 100 in each of these two columns. But what I'm really working with in this question is the sums of 2 dice. So this column right here is the data that I'm analyzing. And if I'm looking at it like that, I really just have 100 rolls of the dice, of the pair of dice. Degrees of freedom would just be 1 less than whatever my sample size is for a 1 sample t-test. And my critical t-value, this is the cutoff. This is what I'm going to need to reach in order to reject the null. It's my target, if you will. I can get that with a formula t dot inverse 2t, because I want a two-tailed t-test. Probability, this is the alpha value, and my degrees of freedom will come from right here, and this will give me my critical t, or t star. And let's take a look just to confirm that on the table that we typically use. So 1.98. Notice here with a two-tail two-sided p of 0.05, I'm in this column right here to find my t star, and my sample size is 99. You can see that's just about 100. Sorry, my sample size is 100. My degrees of freedom is 99. That 1.984 is right there. We don't have the value for 99. That's the advantage of technology. If you're doing this on the test, you can go here in either direction. Typically, you go up to be more conservative. But you can see that the technology is giving us the exact t-star there. Okay, so again, that's our target. This is the target for our p-value. This is the target for our t-statistic. Let's go ahead and see what we got with our actual sample. So our sample mean here would be the average of D2 through D101. Our sample standard deviation, we want the STDEV A for sample, and that would be D2 to D101. And then the T statistic for our sample using the formula. The top of the fraction is the sample mean minus the null hypothesis mean, divided by, on the bottom we have S, the sample standard deviation, divided by square root of the sample size. And this gives me a t-statistic of negative 1.54. To get my p-value, we use the formula t-dist, which gives us the t-distribution. Our x would be this t-statistic. For whatever reason, this does not allow negative, so we type in ABS, which gives us the absolute value of our t-statistic. Degrees of freedom is 99, and we do have two tails, again, because the alternative hypothesis was mu not equals. We didn't say whether it'd be lower or higher than 7. And that gives us our p-value there. So our decision, we can look two places. Let's start with the p-value. So we're comparing the p-value here to the alpha. The p-value was not low enough. It was not low enough to reject the null hypothesis. So we would fail to reject the null. We could also see that by, did we get further than the critical t? So because this is two-tail, we would have had to get higher than 1.98 or lower than negative 1.98. And in my particular case, I got negative 1.54. I did not get low enough to convincingly reject this null. So in either way, these two decision methods will always line up, by the way. In either case, I failed to reject the null. So my plain English was based on this study, there was not convincing evidence to say that the average of 2 dice is different from 7.